plot sin x, x comma, look at the bracket, okay, that if you put a parenthesis, if you put it, you will not find any result, okay. There is a parameter which is going to have initial value and final value, that should be within the curly bracket, okay, right. So if you put this one, you get an error, you can see that the error will be, plot will not be seen. Similarly, table of data, I wanted to have a table of data sin x starting from x varying from 0 to 1 in steps of 0.1. If I don't put square bracket, that generation of data is not possible because mathematics is built in such a way that curly bracket is meant for sort of a group of things that can be generated. A group starting from x varies from 0 to 5, it has a built-in number of points that is already created. So what you do, if I want to correct it, what I do, just look at it what I am doing now, the first statement. I just put a, change the bracket now. Then shift enter. Right, you get a curve. Right? Whereas the earlier things what happened, we have put a simple parenthesis doesn't help within the square bracket. And when you put a parenthesis, when you are grouping, more than one statements are there, then you will do the grouping. Addition, subtraction, division, multiplications are there, you can do the grouping. Second one, table of data, again remove the parenthesis and put the square bracket, because there where you find that this is something which is connected to closing and starting with a set of data that is possible for us to generate for a sin x starting from x 0 to 1 steps of 0.1. If you wanted to have the steps wise, you have to put it within this square bracket and generate it and get the numbers. Now you can see the numbers also available, right? I'm able to see the sign in the physical form, numbers and log numbers. Now suppose I want to generate more number of data, or I would like to extend the x variation for the sine plot. If I make it 2 pi, what will happen? I'll get a full cycle. Correct? You able to get it? Check it, you just check it. Then what do I do? Instead of 2 pi, I make it as a 5 pi. I'm able to get it. Now what do I do? This is sort of a manipulation which I have. I can manipulate it also. It's the same graph. Because your simulation manipulation is possible, I use the statement manipulation. M-A-N-I-P-U, that already available, manipulate is template available, I'll put it here, put a square bracket. So manipulate what? I'll put it as a n here. I'll change the n now. Starting from 1 to let us take 10. Steps up 0.01. Okay? Now you'll see what is happening now. Close the bracket now. Close the bracket. Right? Initially you have a sine pi, 0 to pi. Then I made 2, 3, 4. Now I made the n and I made the manipulative. Manipulative means I have options to change it. Now you see what is happening. Shift enter. So there is some mistakes here. You find what is the mistake. Can you guess what is the mistake in the manipulate? What do you want to manipulate? I want to manipulate n. I have not given the n within the square. So naturally you see there is going to be an error. You get the point what I am saying. When you get error, don't get frightened. See, I have to look at it and then make a correction. Look at what is the mistake in that. N, comma, I missed that. And start from 1 to 10 and I am going in steps of 0.01. The steps also option for me. Okay, now I just enter it again and see what is happening. I am able to see a box which contains a variable n. That n can be manipulated the way I like. Okay, I just change it. It goes up to 10 value. See? You are able to see that? First explanation what we try to do is manipulate. Now I wanted to animate it by just putting it here. Get animation. It's something like progressive. Wave is progressive. Okay. Right? You are able to see that where that is. See sine, we have plotted 0 to pi. Then we tried with the 2, 3, 4. But I cannot do every time. So just put a manipulation and then put that manipulation variable. You are able to see that. Is it clear? Try this. Just make a Entry through those who have options to enter it and check whether you are getting it well or not. How many have you got it? Raise your hand so that I will feel comfortable. Yes, you could be able to get it. How many of you could get this? Enter the statement. I'll just mark it now. Just enter the statement. Then check. Okay? Please, some of them should say, yes, sir, I could get the result. Please raise your hand. How many of you have with the Mathematica working state now with your license? Please raise the hands. I should know how many of them. Please, all of you raise the hand. Those who are already with your license. Raise your hand. You just raise your hand so that I know. Yes. Not many. So
how many of you have license?
License, so that I will realize how many are able to implement it. Otherwise, I can go hard with my totally about 10 people. How many of them is installment? How many of them is around 10 people?
Very more than that. More than that.
What is raising the hand?
Probably this is regarding.
Some of them have problem?
I don't think so.
More than how many numbers can I have?
I can approximate it as that 20 have been installed.
20 people are installed. That means 20 of them should say yes or no. Yes? Okay, please do it. Okay. Even if it's a mistake, doesn't matter. You can always correct it. Say, I made a mistake, I corrected it within no time. Okay. Unless you interact with the Mathematica, you cannot appreciate. Okay. You should really interact and get a feel. Yes, I'm able to get it. I'm going to do many manipulations with this. Just start with the sign. You see how much I'm going to do now. Right? Can I wait for a few minutes? I started with the graphics because that will be attracting people to learn things. Then go to the numbers. Stop it. And you need to stop. Immediately stop. So I want someone, at least one or two to raise their hand. Yes, I could be able to do it. Who got it? None of them could get it. I think Mathematica will help them to see that something is done. Okay, let's go to steps. Okay, let's multiply numbers. Let me do the multiplication. I will multiply a typical number I want to multiply. 1, 2, 3, 4, 5, 6, 7, 8, 9 into 9, 8, 7, 6, 5, 4, 2, 3, 2, 1. What will you get? What will you get? You can do one thing also. 1 multiplication. 1, 2, 2, 1. 1, 2, 3, 3, 2, 1. 1, 2, 4, 4, 3, 2, 1. Like that I will multiply as I will make it a table and look at what is happening. Okay, see, these are just exploring what is happening with these numbers when I multiply one increasing order and the decreasing order. Then generate them and look at something. So I have just taken two numbers which is multiplied and then I look for the number and see what has happened. This is what your number is. Okay. Next, I will divide by what do I get? That 1, 2, 3, 4, 9 will get cancelled. I'll get 9, 8, 9, 9, 8. That's what you'll be getting. Okay. This is what I'm getting. Okay. Let me find out the number n. Numerical value of pi. Right? I wanted to have 100 digits of pi. So I could get 100 digits of pi within no time. Okay. So suppose I want to have 1000, what do you do? Just put 1000 here. Okay. 1000 digits. I'm able to get it. This is just a big easy for people to analyze what is this fractional numbers right? What are the places ones are there? What are the places twos are there? What are the places three are there? It's a big analysis. It's not a small number that you can do wonders with this. You can spend your lifetime on this pipe. You know that? Okay? You can spend your lifetime on this number alone. There's so much great thing that's happening in this number.
What window was easily open? What windows?
Just he can what window? Please help me to open the window. Mathematica window you want to open. Just start take a switch. Because at least 10-15 people should work.
Sir, they are not able to see the curly brackets and other.
Curly bracket are not able to see. So maybe I can increase this.
Maybe I will say loudly.
Wait. Okay.
So you please note down manipulate. So whenever you type manipulate, immediately manipulate will come. From the in the cursor itself, manipulate will come. Manipulate, square bracket left, plot, square bracket left, x, square bracket close, comma, then curly bracket start, x, comma, 0, comma, n with a small space, pi. Pi you are able to type it? Yes or no? Pi you are
If
getting?
you are not able to type pi, just put P-I, capital P and I. That is perfectly acceptable. Capital P and small I.
Pi, after that, curly bracket close, square bracket close, comma, then again, curly bracket start, n, comma, 1, comma, 10, comma, 0.01 or 0.1, curly bracket close, square bracket close. Have you able to do that? No? Then shift enter. Shift enter.
Okay, one more small point here. Whenever you open a bracket, put this corresponding closing bracket there and enter the information within the bracket. Because when you have a more number of brackets, you are always bound to make a mistake. You miss the brackets closing or opening. So whenever you open a bracket, suppose you are writing a curly bracket, close it, and in between you fill the numbers. Similarly, square bracket open, close it. Then put the information what you want to put. Correct?
Can you please raise your hands if you have any problem? I can come and.
Yeah. So many has problems.
So then we can do one thing. You please do one thing. Before doing manipulate, we can plot sin x.
Yeah.
So we will do like this.
This should have the square brackets. That's what we're doing.
Yes, right. Okay, let's plot. I just follow my typing whatever I do. Okay? P-L-O-T, plot. Then capital sign. See, all Mathematica defined functions should start with a capital letter. If you put small letter, it doesn't work. S, small s, capital S, I, N, square bracket should be open because within this square bracket argument should be there for the sign. Sign of x is the variable or argument of the function sin x, comma, make a x should vary now. Is it not? X is a variable. Start from 0, go to. So let's put the Pi itself.
You have activated.
Okay?
You please.
Pi itself besides Pi, capital P and I. Right? Okay? Close the curly bracket. Close the square bracket which you already opened. Okay? Done. This simple thing has been done now. Is it done? That's right.
Hi, activation. You please sit together with someone who has already activated them. It will be happening within half an hour. Completely. Yeah.
You type it now. Sin x. X variable will be fine. See that? Typing over. Done. Okay, now what you do? After the square bracket, keep the cursor there. Shift the enter. This shift the enter should happen simultaneously. Shift and the enter should be pressed simultaneously. So keep your finger first on the shift and then you enter it. You get a result. Right? Shift enter. That. You'll be happy. Okay. Now, instead of pi, make it as 2 pi. See what's happening. You can give the same command. Your option, there are many options available. You can explore the way you like it. But as a starter, you just start with whatever I'm trying to say. So that later on you will explore it. Okay, so make it as a 2 pi now. Type 2 and leave a space. The space implies multiplication. Space implies multiplication. Sometimes it gives an into mark on screen or star can be used. So there are options. Into can be there or leave a space as it is or show a star 2 star pi which is a multiplication. Now you have done it now. 2 star or a 2 pi, leave a space. 2, leave a space, 1 space bar, pi. Right? Okay, shall I enter it now? Shift enter. Shall I enter it? Shift enter. Right? Fine. I find there is a full sine wave. Right? Okay, now instead of 2 pi, I will make it 20 pi. What will happen? What will happen now? I will get a 10 full waves. 10 waves I can see by making as a 20 pi. Because 2 pi is 1 wave. 20 pi means I will get a 10 different waves, 10 different same sine waves. So I will put 20. Put a 20 now. Enter. Okay. Suppose if I put 200, what will happen? What will happen if I put 200? So now you see, I put 200. So which means over a shorter length, I have 200 pi feathers. Which means 100 wavelengths are there, 100 full wavelengths are there within that length. I started with only one. Number of points, what you want, you can add it, but not on that concept. First one also wrong. Manipulation is capital letters should be there, that is wrong. And then instead of 0, somebody typed O. 0 is not the. Okay, next. 200 pi, you will able to get it. I have 100 lambdas available within that length. For an x of 200 pi, for an x of 200 pi, I find 100 waves are there. Right? Okay. Now I will come back to 20 again, so that I see the 20 complete. I am putting too much inside, it's get crowded. And if I reduce the number, it will be, you can see the less number. Right? Okay, what I will do now, I will sin x, I will add another sin x. Okay? Right? Don't do anything, just learn that. Copy and paste otherwise, so that you have a list of program and continue. Copy that, paste it, and put sin x, then another sin x. Do sin x now. Let's see what is happening now. What is expected? This This is what I said, you should have some knowledge about what is going to happen. Same magnitude getting added up twice, which means what you see y-axis unit 1 becomes double. Correct? And same pattern will be repeated. Let's see whether this is getting repeated or not. Y-axis becomes twice. That's what net effect is nothing. Okay? So y-axis will change. See, you have to observe what is really happening. So clear for all that? I just added another sine wave value. Okay. What shall I do next? I do a small change. You find something strange happens. Okay? Let me wait for some more time for the rest to be complete. Okay. Go to the next level. So what do? The second sin x, whatever I added, I will add sin of 1 plus 2x. Sorry, sin 1.2x. Which means one place I have a phase of x, another place 1.2x. That's all, I'm not going to do anything else. Right? Look at same thing. Just enter and see what's happening. You follow what I'm saying? 1.2. Multiply, give a gap. 1.2, give a space. Will I enter it now? Let's see what is happening. Already entered? Somebody has entered? What did you find? What did you find? What is going to happen? What do you call it? Something strange happened. Things have completely changed. Is it right? You see, something strange is happening. It is actually, you have two signals with a different frequency. X and 1.2x. You see the peaks. There's an envelope is there. Okay? There's an envelope. You can add this, if you do this trigonometry, this sine of x plus, which means sine theta 1 plus sine theta 2, what you get is something. Algebraic changes, and the product is going to be an envelope of one wave and the inside another wave. You are making a group of waves, so already two words are added up. The different figure. Right? Okay? Understand? You find there is going to be a group of waves. Now I wanted to see what are the possibilities for this group waves when I manipulate it. What is the manipulation? 1.2 instead of that, I will put some n. Change that n. Starting from 1 to say 5 to 4. What are the wave like? See what is happening to this wave? Right? Understand what I am saying? I have sin x plus sin 1.2. This is the wave. I don't want to change every time. See, for example, I change a parameter like 1.1. Okay, before that, instead of 20, I will make it as 40. Okay? Or 30 I will make. So that I see more number of big waves within that. So, see that I can see more number. Say, instead of 20, this is what my result corresponds to 20. I just make it as 20, I make it 40. Okay, you can see the bead formation. Right? Addition of two waves, which gives something very interesting. Now what do? I want to manipulate and see what happened to this combined wave. Okay, what do? I do the manipulation. Let us see manipulation and what result I am going to get it. So manipulation is on the variable 1.2. I just put a variable there. Vary that and see what is happening. Okay? Let me do it. You can also do it. Did you check this one? 45? Who got this result? What they have to screen? Anybody got this result? Nobody could get this one? Only one. This side? Two, there. Back side. Not bad. So I can proceed manipulation. MA. When I start typing MA, it's already manipulation is available. I don't have to make typing. Even if you make typing, you will make a mistake. Okay? I type NA, N is not typed. By the time I have a main plate, I just press this main plate that goes into the system. Then open a square bracket at the main plate where you are completed. Right? Then open the bracket. I have to close somewhere. No? Closing will be at the end. Okay? Before closing, I close it already. When I close it, it's asking something. Red color cap. Right? Now what is that it's asking? What is the variable you are going to define that? My variable is, let us take, I am going to make this as an n. Remove that 1.2, make it as a variable. The variable is going to change from n, varying from, let me start from 0 itself, 0 to 10. Then what step you want to have? I wanted to go in steps of 0.1. Okay, close the bracket. Complete this. That? Okay, let's see what's happening. So, x0 to 445, and then x2 is the variable now, you have an n that we are going to manipulate and see what is happening. Enter now, if I enter it, what will happen? It's the first step, what do you get? Now, you should in the question to check what is that I am getting in right or wrong. Yes, n equal to 0 is the first value, which means second component disappears. Sin 0 equal to 0. You don't see anything, correct? Fine. Now I change the n value a little bit, okay? And see what is happening. Okay? Very interesting to see. What is the value of n right now? 0.1. If it is 1.1, this is what happening to the wave. I increase it further. 0.3, this is what the wave. Okay? I'm going to change it 0.6, this is what the wave. And when it is 1, this is what happening. What happened to the 1? You already done it. Sin x plus sin x. Two waves are added. Exactly with the same phase. Okay, when it is little phase is changed, then you see the beating effect. You see, then I will change it to 1.2. Then go to 1.3, 1.4, 2.2. Yeah, go ahead with that. And then check what is happening to the wave. Instead of going ahead with each step, click that arrow mark and then see what is happening. It is evolving with n. That's what the result we have. You have so much of signal that we have generated. Amazing signal that has been generated. Okay? It's very simple to see that. And you see how the sine function is behaving and adding a sine function to what is happening. All the consequences you have seen. Okay? Seems to be interesting. Ready? Then? Unless you do it, appreciate if you do it. Fine. Now what do? I look for where the, this is what I have.